Today, I'm going to talk a little bit about making meaningful or useful API contracts. And by that, I mean having a contract between an API and its users in terms of how that API works. The whole thing, I'm planning to do it in around 45 minutes and then leave the rest of it open for questions. First 15 minutes going to be this presentation. And after that, we're going to jump to some coding examples. And if that sounds good to everyone, then I'm just going to introduce myself. My name is Balazs. That's a picture of me. And I'm working in the Budapest office, or I should rather say my Budapest living room. And now back to the API contracts. First thing, what I'm going to show you is an example, or at least how I have seen this in real life going when backend is in its basically in its infancy. It gets started, and the backend guys are giving it over to the frontend guys to start the development on it. So in order to demonstrate this, these will be our protagonists. On the red corner, this will be the backend developer. On the blue, the frontend. And it all starts by the backend guy basically saying that we are done with the backend. Here's a URL, check it out. After that, it's usually, I'm getting no response, any idea why that's happening. Asking some basic stuff, did you hit it with the get method? Yes. Oh, I forgot to tell you, we need a custom header. Okay, now I get data back, but I get a million records. Is there a way to paginate this? Yeah, use this and these parameters to do that. Okay, so after this exchange, most likely, especially if the time zones are different, so for example, one of them is in the US, one of them is in Europe, people are not going to be happy since a lot of time has been wasted with figuring this stuff out. What could have been clear from the start. And the situation gets even worse after a few weeks or months pass and changes have been made to the backend, but nobody really knows about it except the guy who makes the changes. So after this, it often happens that we are getting a 500 error for stuff that we earlier got a decent response back. Why can't that be? Send me a payload. Here it is. We added a field that you have to send. And then fields start to go missing. And it turns out that you need to make different requests since the API have been restructured. So I'm not really sure if this sounds familiar to anyone, but I think it should, since most of us see this kind of stuff from time to time. Now, after this, obviously, the mood is not getting any better. But what is the problem here? In my opinion, the problem is that we have no formal contracts in most of the cases between the client and the server. By formal contract, I mean that most of us, I think, are working with statically typed languages. So front-end people, most likely with TypeScript, back-end people with Go or Java, or also TypeScript on Node. And here, when you are using libraries, then you have a clear contract of what you can expect from that libraries. In TypeScript, TypeScript's gonna be the main topic of today's talk since I'm a front-end dev. But in TypeScript, you have the type definitions, what clearly describes what you can expect from a library. In Java, it's part of the jar, and I have no idea what, for example, Go does in this case. But in each case, you see exactly what the library exposes. And in my opinion, we should think about the API the same way. Having an API should really describe what it does. It's good for the backend developers as well, since they want to be exposing their APIs to its fullest and want people to be using it in the way it's intended to. And the front-end guys really would like to understand what the backend actually does. Excuse me. So the solution. We have had solutions for this kind of stuff for a long time. The first initiative for this, as far as I can tell, was Swagger, which in these days is called OpenAPI, which solves this for HTTP. That's going to be today's topic. But for two-way communication like sockets and other alternatives, We have async API, which is a newer contender, and there is also GraphQL that solves both. I'm not going to talk about that today since I'm not really sure how much we adopt that at the company, and I don't really have anything to show you around that. But the way the first two works is basically define the structure of your API in a static document like JSON or YAML. And in this case, this is just a very simple example where there is an API that exposes a user's endpoint that you can hit with the get request method. And the only response that you can get back is 200, so you shouldn't expect any errors. And the MIME type or the format of the response is going to be JSON. And here is described how the JSON looks like, which tells us it's going to be an array of strings. So the question is, why are we not using this? I have two answers for this. If you just have a document like this written for your API, there is really no incentive to maintain that if that's not really part of your code base. It's not any different from a harder to read Confluence page. But how can we make it part of the code base? Well, one obvious solution would be for that is to generate code from that. So for example, from the client side, we could generate code that interacts with the backend. That's going to be the main topic for today. And for the server side, we could also generate the harness for the whole thing. And you could only, or it could expose stuff where you only need to provide the actual business logic for your server side. So in terms of the code generators that could help us, I have tried quite a few that I could find on the internet. My most obvious solution a few years back when I needed this for a TypeScript project was the default OpenAPI code generator for TypeScript, which was fairly hard to run. I had to install Java, but a specific version for Java to actually make it run. Then I had to download the code base, which wasn't really working on the master branch. So I had to roll back to a specific commit figured out from some issues on the page. And after I run it, the output was fairly questionable because it wasn't really useful. It wasn't what I wanted. And the generator really didn't provide any option to customize what I'm getting. So it's take it or leave it approach. Now, here is where a big shameless plug is coming in. This is a library I have been working on roughly since I joined the company the last 4 or 5 months. And what it aims to do is solve, at least for now, the client-side problems with this. So once you have an OpenAPI document, you can set it up and generate the whole infrastructure around working with the backend that the OpenAPI describes. So if you come to the GitHub page of this, you will see it's a big monorepo. So there is quite a lot of stuff in there already. The next, what I have in plan is going to be async API. So that's going to be mostly for WebSockets, so two-way communication. But for now, today's topic is just going to be OpenAPI. And in case you want to read about this, I have a moderately up-to-date and fleshed out wiki what describes what this does. But since we have time today to actually look through this, I decided to just do a bit of a coding demo. Before we do that, any questions so far? Or any observations, anything?
No, pretty much is very clear. Thank you.
Cool. Okay, so I'm just going to jump over to the demo. We're not going to need any of these, yeah. So for the demo, what I have here for you is basically a node project. I didn't really put too much stuff in it. Sorry, someone has the microphone on. Could you please mute it? Thank you. So it's basically a node project. I have a few dependencies filled here. I'm not really using this machine for development, and the NPM install wasn't going through the Netscope client, so I kind of had to pre-install all of this. I wanted to show how to do it, but I'm going to show it anyways. So in case you want to mess with this library, you can come to the wiki, go to the packages section, and depending on what you want, OpenAPI or Async API further down, here are the full installs what you will need. So you can copy this and run the install commands. The first will be stuff that's needed for generating code with this, and the second one will be stuff that you need at runtime. But anyways, I'm going to go through anyways on this when we get there. So somehow I made it disappear. There it is. So here are our dependencies, and now I'm just gonna write some generator code for this schema. That's gonna roughly do what we described in the initial interaction on how this might start out, how an API might start out when you start working with this. So this is an OpenAPI document. I just closed everything so we can go in step by step. The most important parts of this are basically paths, which describes the actual URLs that you can hit. And the components part describes the reusable parts that you can use in either other components or in paths, or basically anywhere in parameters, whatever you wish. Now, in these paths, you can see under a certain path the request methods that you can use to hit that path. And when you open this, this is where the whole operation, OpenAPI calls it operation, is described, where you can see responses that you can receive from this API. So for example, what kind of schema, response schema you need to prepare for in case you receive a correct, a 200 response, what do you need to prepare for if it's a 400, and so on. And it also, in case it needs input, for example, a request body, you can also describe that here. And also parameters, basically anything that you can think of. There is a schema for this on the OpenAPI documentation. You can check that out, how to write this kind of schema if you are interested in. But there are also tools that generate this from backend code with more or less success. In my experience, less success, so it's kind of worth to write this by hand. In the components part, the most important part, I think, is schemas, which you can think of your type system in this case. And this describes basically in JSON schema format certain pieces of the exchange data format that you can expect. So for example, here is how we describe a book that we will receive from, let's say, the get books endpoint. And in this case, this will be an object. Some fields will be required on this. And here is the full list of fields that it has. These are basically JSON schemas themselves, so they can be references, like in this case. And yeah, that's about it in the schema section. This can describe mostly any type that you can think of in TypeScript terms as well. So for example, you can describe enums with this, and you can describe union types, which will be polymorphism, stuff like that. It's kind of powerful, maybe a little bit too powerful to a strictly type system, since you can do really silly stuff with this. But anyways, that's our schema that we want to generate code for. To actually get started with the generating, first I'm just going to make a plain old TypeScript file and make sure I can run this. So this is why I have TS node installed, so I don't need to compile this. And I'm just going to make a shortcut here to run this file. Let's test if that works.
So Balazs, I'm not seeing the screen you're updating. Well, I'll find out if you can, sorry.
Are you guys not seeing my screen?
Yeah, we can see that in the terminal below, at the bottom of the screen now.
Oh yeah, sorry.
Must be my screen resolution. Sorry, my bad. Cheers.
Is it better, Mo?
Yes, much better. Cheers. Thank you.
Cool. Yeah, sorry. So I can run generate. That's cool. And now the generator part can begin. So most of the time when you see these code generators, it's exposed as a command line utility, which I didn't really want to do, since that's exponentially getting harder to add new plugins or add new stuff to or replace parts in it. So I wanted to do the whole thing in code in TypeScript, kind of like how you do your Webpack config. I found that's the most flexible. So the first thing we need to do is import the main generator harness that will orchestrate everything. That's going to be in this generator package. There are actually examples, like full-fledged examples on the wiki page as well. So I'm just going to show you this as we go, but that explains as well what is what and why is it there. So this generate function is taking care of making sure that things work together. And this is a simple function that needs an object argument that will configure it, how the generator wants to be run. Now at this point, this is not really tied to OpenAPI or any other format. That will be defined by the configuration that you pass in here. And I think that's a good way to actually in the future provide more stuff for this as well. So the fourth step that it has is, if you look at the options, is it needs to read your configuration. That's going to be responsible for this reader. Once you look at an OpenAPI document, it might seem like a simple JSON structure, but when you look at these references, these can point to other files, and those can point to other files, and those can point back to this file. So it gets kind of complicated when you want to resolve this, especially if it's on a remote. So that's the reason why this reader is basically taking care of simplifying that. And that's going to be imported from the OpenAPI reader package. And I need to pass it in where you want to read from. So here I'm simply passing in the schema.json file. Now that this is done, the next step would be to provide some generators that take the output of this reader. That's generic, by the way. So that's a generic OpenAPI read output that the generators can consume and generate whatever they want. For now, I'm going to leave that empty. We're not going to generate yet anything. And in the end, I need a writer. This will be that takes the output of the generator and turns it into code on the disk. So what we're going to use for this today is Typescript Writer that will take basically TypeScript syntax tree and write it on the disk, since that's what my generators, what I provide by default for these, create. So for this, one argument is necessary. How do you want this to be stringified? Since in the last 4 or 5 years, I have only seen people format TypeScript code with prettier. The only option I expose in the package by default is a stringifying method that does this with prettier. And actually, if we had one prettier config in this project, I could just read that in and pass it in here. And whatever we are generating would be formatted the same way as you would expect all your other source files in the project to be formatted. So here I'm just going to pass in that the parser is TypeScript. Now, I can run this generator now. And hopefully we see an output. We don't, because I didn't put logging on. Now it says the read step was successful, meaning that we could process the schema, and the write step was successful since it needed to write 0 modules to the disk, meaning it didn't do anything. Now, the next thing I usually like to do when I'm working with a new system, I like to understand the types that we have. So in this case, what we have in the schemas. There is one generator that does this and generates us static, I think fairly decently readable TypeScript types, which gonna be this types generator package, which we can import from one of the packages of the module. And this also needs a configuration. And here is where things start to get a bit interesting. Remember, in the beginning, I said configuration and allowing customization is a big goal of this. So because of this, you can fully customize where you want to put your types, or basically everything that you generate with this path function. And also you can customize how you want to call them. So in this session, I don't really have time to get into that. If you are interested, I'm happy to do later a deep dive on this as well, if anyone is interested in this, or we can do a follow-up session. But for now, I'm just going to use defaults for this, that one of the existing packages provides by default. Oh, this one. I'm going to use the default path provider, and I'm just going to tell it where the root of my types is going to be. So I'm going to generate everything in source/generated. And the next is going to be how we're going to call stuff. And that's going to be basically trying to figure out cleverly from the OpenAPI definition what the different types, what the different operations and everything should be called. In this case, I made my job easy since I gave everything reasonable names. In case you don't do that, it will try to turn the default name provider, at least everything that's a type, into a Pascal case name, everything that's going to be like a function, what we're going to do for operations, it's going to turn it to a camel case name and so on. So it's going to do its best to have stuff that's decent to work in TypeScript. But obviously you can provide your own if that's not your cup of tea. Now, once we run this, I know this was a slow start, but now you actually start to see some results. Now we have types generated for all the guys here in the schemas. So let's have a look at, for example, this book type. That's a TypeScript type formatted with prettier, and the imports obviously properly resolved because without that it wouldn't really make any sense. So this book type reference is another type, just as in the OpenAPI document. So this reference is here as well. So that's all good, but this is not really useful since we want to interact with this API. So in order to be able to do that, we need another generator, which will generate all the operations for us. So that also comes from the package, one of the packages, sorry. And we can use it the same way as the types generator. And you also need to pass in the same stuff, but I don't really want to repeat myself, so we can just reuse this. Oh. Oh. I have too many compile errors. Or the TypeScript service just gave up. No, there it is. Generator config. That's the type of this. This is what all the generators that I provide by default need in order to know where to put stuff, how to name stuff, and where to put stuff. And that's that everybody is going to need, or at least the ones that I provide by default. At this point, you can start to see that you could write your own generator that confirms to certain features, and you could generate whatever you want. You could generate from a reasonably normalized OpenAPI format, React components, or whatever you want. Or in the future, something that I'm planning to do, you could also generate server-side code. Now, let's try what happens if we generate again. And what we see now is an error. Now, what is this error? These generators can establish basically a dependency hierarchy. They can say they provide certain artifacts and they want to consume certain artifacts. So for example, in our case, the operations generator depends on our types generator. And here it complains about that it depends on another generator's output, which is all the parameters like the headers, the query, and the path parameters. So these are basically arbitrary strings, what you see here. And in case you want to write a custom one, in case you want to replace, let's say, my types generator, you could write one that provides the OpenAPI /type artifact, and then you can plug in your own in this, and all the other generators can pick that up and use it. Now, I don't want to get too much into this. To solve this error, what I need to do is import another generator here, which is parameter types. And after that, I can actually successfully run this. And in the generators, now we will see that we have our types, and we have the 4 operations. What we had in the, sorry, this is not important. The 4 operations that we had in the OpenAPI document here. So one under the one with a parameter in the URL and one without, and each of them had 2 different operations, one with get, one with patch, and post, respectively. So if you look at what these do, they are basically simple functions, and the good thing about it is that it takes care of most of the stuff that is known in advance. So for example, the URL. And in case you have parameters, so for example, request bodies or path parameters, then it will also take care of that. Because if you look at how OpenAPI path parameters or query parameters are serialized, there is a million different methods, and you probably don't want to do that on your own, because it's a huge pitfall. I have worked on the parameter serialization for roughly a month. There are so many options in this. So let's see this in action. So what I'm going to do is, I think I have already started. I started a demo server running on this localhost 3000 that basically conforms to this API spec that we just described. And we're going to try to talk to that from our test. Now, the first thing we need to do is import the method. The simplest one is getBooks, which for some reason I don't receive any content assist for, so I'm just going to import it by hand. Generated /operations getBooks. There it is. And I can call it as a normal function. It's an asynchronous function, so it will return a promise. So I can wait on this. And we see that we have a compilation error since it needs a parameter. So what this parameter will be is something that all these generated functions will need, which is basically the whole customization on how you want to execute this HTTP request. Since a lot of people want to use a lot of different request libraries, some want to use the built-in fetch, some wants to use Axios or whatever people use these days. All of this is configurable through this request config object. And in case we were to use another type of request which actually needs parameters, so for example, a request body, query parameters, headers, or anything like that, that would be another parameter. But that's the maximum, that's the extent of the parameters that these functions need. So in order to actually use that, what I'm going to do is import and use default ones that I provide with this HTTP library. And that's going to use for node fetch, and for the browser, it's going to just use plain fetch. So here I'm going to just create this request config. And if we see what parameters it needs, it basically needs a function that describes how do you make a request from a normalized description of what the request parameters are, so the URL, the method, so on. Then it needs a parameter on how to serialize a request body in case there is any. And then all of these, the body, the headers, the MIME type, the status code, are functions that describe how you want to get stuff out from the response. And the validate function will be basically describing how you want to validate responses in case you don't trust the server. And this base URL, since I'm not really sure if I showed this, but in OpenAPI, the convention is to define just partial URLs. So it's usually not described fully, so you don't see http/something something. Because of this, you can provide a base URL that will be concatenated with the interpolated partial URL. So in our case, that's going to be our localhost 3000 where the server is running. And all of this stuff, for this, we're going to use the built-ins from the package, which is going to work for node fetch. And you see that the import path is a little bit more complicated here. That's because I provide by default fetch and node fetch, and I don't want you to mix it up in case you want to use it, so you don't accidentally import node fetch in the browser and the other ways around. Even importing fetch in node wouldn't really be that big of an issue, but still. And from this package, you can import basically everything that is needed for configuring this with node fetch. So most of this stuff can go in just as it is. The request for this, what I let you do still is there is a request function here, but you can configure it with the parameters of fetch. So in case you want to, let's say, enable course or enable any other trickier settings on it, then you can do that here. It looks like I messed up the typings for it. I'm going to fix that later. But you could provide, let's say, mode equals course if you were in the browser and you want to turn that on. We're not going to need that for now, since this is not something that you can specify in the OpenAPI document. And the validate, for that, we're going to use just nope for this. Since we don't want to validate it, that's a whole another story. But now when I pass in this configuration and I execute this request, hopefully I will see a reasonable response. NPM Test just runs this test file that this lives in. And so what we see here is the full response that we got back from the server. Just as the schema described, it's a list of books. Here are some headers, the MIME type of the response, and the status code. This will be important in a second, and also the URL. So now if we actually want to process this, so want to check out what's in this response, how you would work in this in TypeScript, then the first thing, the most important thing for you and probably for everyone, is checking out the response, the actual response body. Now in this case, we see that it's either a book or an AppError. So why is that? What we described in the schema for the get endpoint is when we get back 200, then it's going to be an array of books, which is fine. But the OpenAPI schema also describes that in case we receive a 400 or 500 status code, then you need to expect an error response, which will give you back this AppError schema. So now which one is it? If I just use this body, I can't really make that distinction. But since the status codes in the OpenAPI document clearly describes which one is it, this can be used as a discriminator here as well. So now if I check if the status code is 200, which can be, by the way, here, you can see statically that it can be 200, 400, or 500. Body is automatically typecasted to book. And in the else branch, since both of them have the response as AppError, now this is an AppError. So most of the libraries I have seen doing this throw whenever the status code is not 200. I don't want to do that since TypeScript or JavaScript cannot really handle reasonably thrown stuff. So in case you put stuff in a try catch, and even if I just throw stuff here, the catch will be always any, and I have no option to actually give it a type. So with this, if you would have any other responses other than 200, you would need to work with any, which is absolutely not useful. That's not what TypeScript is for. So for this reason, all the status codes are handled the same and nothing is thrown. And the way this is actually described in terms of types, here in the response type, it's actually listed with a combination of the type itself, so the logical type, the status code, and the content type. Now, that's all good, but what I described in the beginning is that it can also help us with changes, so changes happening over time. So let's say from the response body, I write some code where I take out the first book, so this will be a list of books, and I console log this book. Maybe not the book itself, but let's say I console log the price of the book, and I commit this. Oh, Jesus. Anyways, I don't really have this set up on this machine. I usually work on a remote, so forgive me, I don't have Git set up. So let's imagine that we committed this. But now, let's say the type system or at least the provided APIs change on the server side, and they modify the OpenAPI document, and they change this to cost. Now, usually, if this happens and you don't have this synced up with code generator, you will figure it out by either something throwing an exception at runtime or seeing an empty field for your price on the UI. Now with this, what happens when you regenerate? Is obviously I will get a compile error since this price fields now no longer exist. But I will see the cost there. So with this, you basically save yourself the round trip of first seeing the defect, then trying to figure out why that happens, then trying to track that down in the code where that's actually being used, and then figuring out how you want to deal with it. So you straight up see a compile error, and you can see that something is missing. I wanted to show it with a git commit, since then you would see the diff in the generated output as well. But that didn't really want to work. But you can see it in the type as well. Stuff is updated. So I'm just going to quickly revert this, since I think the server will scream if we try to make exchanges like that with it. But there is one more thing that I would like to show you, and that's going to be how you would actually practically use this. Since these small functions that make these requests and you have to constantly configure them, these are not very friendly for front-end code, since this is most likely something that you configure in advance and forget about it, or at least that would be the ideal situation. So going back to the generator, there is one more generator that I will show you today, and that's going to be the API generator. If you have any better names for this, I'm happy to hear it. This seemed like the cleanest to me. And what this does is it will generate a type, a class, and some other stuff that will help you interact with your whole API and configure it once. So let me rather show this. So now here we have 3 different outputs. First is API type, which describes all our operations, just as in here. And then you can see that here the configuration of it is optional. So you don't have to pass this config object in each time. And how is that possible? It basically has a very simple API implementation generated, which has this configuration as a field. It takes it as a constructor parameter, and from then on, anything that you pass in as a configuration will be merged in with the existing configuration. So the way I would use it is, let's say if I was using a React project where I want to make HTTP requests from various components, I would create a I don't have content assist. So I would pull in this API implementation and create a context that shares just this API type. Now this way, all your components can make API requests through a uniform interface. But most importantly, you can use, let's say, this stub for testing, where you just overwrite a certain method and return some dummy data. Or you can also create a full custom implementation of this in case your backend is not complete, only the contract, or your backend is partially complete and stuff is missing from it. You could patch it up, and later, without any changes to the code that's using this, you could just swap it out to the real actual backend or the real actual implementation of this, and that would interact with the actual backend. So I think that's all the demo I wanted to show today. Oh yeah, sorry, I wanted to still show that you have these methods, and in case we call this getBooks, let's say, you don't need to pass in anything. In case you have parameters, just get one simple book that needs a path parameter, that needs a book ID, and here you would pass in your book ID. So fully statically type everything here as well. Now, that's all I wanted to show today. The repo URL, I'm just going to share it now in the chat. And remember the wiki section if you want to learn more about this, that explains stuff. But also, I'm very happy to help anyone with this. If you are interested in it, want to contribute, want to start using it, just book a meeting with me anytime you see a free slot in my calendar, and I'm happy to help there. Let's try to find the chat here. In the future, I'm going to do the same thing for OpenAPI. So there you would be able to do the same thing with WebSockets. The difference would be that the async API spec is not fully fleshed out, or at least not as mature as OpenAPI. So there is still some discussion about that going on in the async API repo. So yeah, now I'm really finished talking, and I'm open to any questions if anyone has any.
May I ask some question?
Sure.
What about if HTTP status is 302? I mean redirection. Is it handled somehow? No.
Very good question. So the philosophy of this, or at least the generators that I wrote for this, is that if 202 is something that you want to expect, where is that? So if 202 is something that you expect to be receiving here, then what you should do is define that in your contract, that 202 is a valid response status code, and define what you should expect here. In case it's not in the OpenAPI document, now that's when the code that I wrote will start to throw, since that's something that's not expected by the contract. So you are basically breaking the contract if you return that from the server. And why should the client expect that? So that's something that should be ironed out during development.
So I have to do it manually. It's not supported out of the box, right? 302, I mean redirection must be implemented manually, right?
Yes, yes.
Okay, see.
I have a question, and it's regarding the implementation of middlewares here. I like the idea that you generate almost all the structure from the contract, but I wonder if inside of the contract you define when to import middleware that, let's say, consumes a database, and I export that data into the endpoint. So it is possible to do middleware here?
So in this case, we are just on the client side, and we are just making HTTP requests. All the server side work is not done yet. So I am planning to do stuff that that generates server side code, but it's not done yet. The stuff that you see running in the background, that's like a custom handwritten server, this demo server, if that's what you are asking. So
I see. So what we received, so what we expected today is just the client side and the generation of files for us to consume data as a client.
Yes. Sorry, I forgot to mention that.
Okay, perfect. I will be waiting for the server side. This is gonna be wonderful. Thank you.
So I created an issue here on the server side stuff. I have some ideas as well. Maybe not. Oh, issues, sorry. I'm blind. So here I have some ideas on how to do this, but it has its own challenges. And since I'm not really a server-side developer, I haven't really started work on this. But this is something I'm very interested in doing, since if we have that, then we basically have all the formalities out of the way, so to speak. So we don't need to worry about the structure. We have one document that's the golden source for everything. And from that point on, both the client side and the server side can adhere to that and just update that when changes happen. So I really would like to do that, but I really need to invest more time on the server side, like how that works, how that's idiomatic, what kind of libraries people do like to use. Is Express still something that people use for backend development and so on? So
actively.
Hey Balazs, this is Kritik. Quick question.
Sure.
Yeah. Okay. So sorry, a couple of thoughts actually. So a lot of our clients are using Swagger and now API or whatever, and I totally sympathize with the rationale with what you're doing, because literally the Swagger code gen library, the Java library that you're talking about, really sucks, and we know this because we have been using it for a while. I think one thing to consider is how to operate with Swagger at scale, right? So if you have a larger organization where you have a lot of UI code or API clients being built, how do you scale the process, right? So for example, who owns the Swagger API spec? Should it be owned by the backend or by the front end? So that's one question. But let's say that even if you figure out who owns the Swagger contract itself, what is the central repository that reflects the source of truth? So for example, in this case, the client-side code had the code gen sort of written in the client-side code base, and it can then import the Swagger code gen from a remote location probably. But if you have multiple clients, should all of them do the code gen separately? Should it be part of the CI/CD for the Swagger spec? So do you have any thoughts or does that question even make sense? Or maybe it's a second order problem.
Absolutely, it's one of the most important questions since lots of problems arise from this, like not really being sure on who owns this. In projects that I have experience with, the owner of this was the backend, but I'm not really sure if this is the best case. So I would suggest this in case we are working with, let's say, a client who owns the backend, and we don't really have any say in what the backend code does. So then just having an open API document that hopefully is reasonably defined for us to consume, that's great. But in case we are doing both, we are doing server-side and client-side development, I think this should be the responsibility of both sides because server-side code usually tends to conform more to what's easy on the server side. And sometimes clients just struggle to actually use it. And in my opinion, it's a great way to talk about this and spec out this schema commonly, like together with both teams, so that the final output is something that's good for both. In terms of structuring this, the way I would do it is basically have, this is a very idealistic approach, but what I can think of now is have a repo basically based for just to the Swagger definition, and from that point on, when that repo changes, it could be part of the build to do this generation, so that both the client and the server could pick that up eventually, the generated outputs. I'm not really sure if this would work. This is just something that popped out of my head for now, but
yeah, I mean, if you're interested, Balazs, we can take it offline. But I mean, Troy is there on the call. We are using it extensively, and there are massive problems with the way the code gen is working. Like the TypeScripts are like weird, unreadable. Like basically all the problems you said is manifesting right now in this organization. And I'll just make one more point, and then I don't want to steal all the time. But the other common problem that we should also sort of think about is that in reality at scale, the way updates happen to APIs is that a backend engineer would go and make an update or add a new API. And then it's a reverse code gen, right? So instead of contract first, it becomes sort of code first, even though it started as contract first, if you see what I mean. And then somebody writes a code, and then there's a CI/CD that then spits out a Swagger file. And then that Swagger file is consumed by another process that spits out the TypeScript file. And now this whole thing is a big mess. So I think it'll be an amazing thing if we can sort of come together and think of a scaled process for API management through contracts, if that makes sense.
So if I may interrupt just to answer your question from previous experience working as a full stack dev before joining Lab. So yeah, so the actual Swagger API needs to be full control, full responsibility of the backend team, and it's usually as straightforward as just annotating the backend API files. In terms of changing the API itself, so if you can scroll up to the top of this schema JSON, there should be a version somewhere. There is a version. So what usually happens with backend is that every change, especially breaking changes, you will release a new version. So multiple client and you will teams will actually have multiple versions of the same API running in parallel if they support multiple clients. If you only support one client, then this is pretty easy to mitigate. But if you have multiple clients, you need to support multiple versions at the same time until everyone has stopped using older versions of your API. And this means that each of the client might have a different API version that they connect to, and then you will have a you will need to generate basically the front end files to connect to the backend yourself. But usually, what's done is as a part of the build process, you would check if the files that you have match what is actually there on the backend.
Yeah, I think what Krutik mentioned is that the stuff that the default annotations and the I don't really know if that's those are plugins or whatever that happens on the server side, usually in Java or Scala. The output of these is usually not very neither readable or.
I mean, at that point, those Swagger files are unreadable because
Yes.
literally the Swagger code gen, which does the, it's called Spring Fox in case of Java, but when you annotate your Java code and add those Swagger annotations, the output is fairly unreadable. So yeah, then it just becomes an artifact for further code gen, but the document itself becomes useless. I think that's it's a very philosophical discussion actually. And I think a lot of people have thoughts. I was just wondering if we should create a separate group. Balazs, if you want to lead that, I think it can be very useful to many of our clients. So we can take it offline, some of these questions.
Awesome. Also, if anyone else is interested in this, I think it should be a good idea to either ping me or Krutik about this, since I'm really invested in developing this further as much as my free time allows me to.
Hey, Balazs, I have a question too. You showed writing some unit tests here, or I suppose integration tests. I'm curious if you think that it would be possible, and if so, valuable to also generate some basic integration tests. And here I'm thinking that you could, validate that when you're running against the server in some given environment, that what's actually happening in reality conforms to what the spec says. Do you think that would be feasible and within the scope of this library to do something like that?
It absolutely could be. There is no technical limitation to this. So you could definitely write a generator that creates these test cases, for example, for each of your endpoints. It could be done. It could be interesting though, since if it's a real server, data changes. So you always have to start from scratch or make the request in a way that they don't expect the server to be in a certain state, especially the methods that or the endpoints that retrieve data. But I think it's definitely an interesting thing to do, to actually have automatically generated tests that tests if the server is actually doing what it says it does.
Cool, thank you.
Actually, Balazs, another related idea to that particular thing would be to actually consider generating a stubbed server implementation, because, and correct me guys here, I mean, I don't do as much front-end development as many others here, but most of the time front-end engineers are creating mock servers anyways, right? Because when you're doing local development, you are using some sort of a dev server implementation. So if it's possible, I know Swagger CodeGen can do that, but if there's a possibility to also spit out a stubbed server implementation, it will make lives very easy for.
So that's what I try to point at, is that if this is your only interaction with the API, so this typed list of endpoints basically that's in the format of TypeScript, then you can make a mock implementation of this where you return dummy data or data in memory, And you don't even need to make a connection, since you can seamlessly plug this in instead of the actual implementation that really connects to the server and makes requests. And this is the interface that you need to implement. So I have done this in a previous project where the front-end development was far ahead of the back-end development, and it was working quite successful. So we were working with a custom implementation of something like this in the past version that I have done there. And that was doing stuff in memory. So basically not even making HTTP requests. And then once we plugged in the real backend or the real API, so to speak, whatever you want to call this, so the version that actually makes requests to the server, there were very minimal changes that needed to be done, mostly of how we handle async stuff, but that was it. So it's very possible, and I think it's fairly simple to do this kind of stuff without even setting up a full mock server.